Hello, welcome to Flip. So today we are on purification and analysis again. We are on distillation and fractional distillation subtopic today. So in our previous videos, we have learned how to separate, for example, solid mixture and solid liquid mixture. Today we'll be touching on liquid mixture, okay, using distillation and fractional distillation, which are really almost the same thing, but I'll tell you the difference between them later. Let's start off with distillation. Okay, distillation is really just to separate liquid mixture. Basically, okay, the principle is that different substance have different boiling point. Okay, so this means that, for example, substance A, okay, its boiling point is 100 degrees Celsius. Substance B, its boiling point is, for example, 150 degrees Celsius. Okay, so when it reaches 100 degrees first, 100 degrees Celsius, this one will come out first. This one will remain in the mixture, for example. Okay, when it reaches 150 degrees Celsius, this one will then come out. Okay, so this is the principle behind this distillation. When I heat it up to 100 degrees, only one of the two will come out. Okay, let's see how it's done. Okay, the procedures wise is quite simple. Okay, you really just have to heat it up, heat the liquid mixture until thermometer gives a constant reading. So for example, I have a mixture here. For example, I have ethanol, okay, and water. Okay, so they mix well. Okay, this is like an alcohol solution. They mix quite well. So you can only see one consistency here. Okay, actually it's quite transparent actually. Okay, so for example, if you heat it up until 78 degrees Celsius, okay, what happens? Let's take a look. Okay, let's use pink to indicate ethanol. Okay, so when you heat the liquid mixture until thermometer gives a constant reading, okay, substance with the lowest boiling point starts to boil. Okay, so for example, ethanol is inside here. It boils now. Okay, it starts to boil. Whereas the whereas the water, which boils at 100 degrees Celsius. Okay, maybe I should just write it down. Water boils at 100 degrees Celsius. Ethanol boils at 78 degrees Celsius. Okay, so at 78 degrees Celsius, which is the lower boiling point, okay, the vapor of ethanol starts to leave the flask. Okay, so it's like that. Okay, and it will go here. Okay, it will go through the condenser. Okay, which is this one. This is a condenser. Okay, whereas the water comes in here and the water goes out here. Okay, so what happens is that vapor leaves the flask, okay, as with this pink arrow, and condenses back into liquid and is collected. Okay, so when it rises up, okay, then it touches a cooler surface, then it goes down here and it's collected here. Okay, so this is where all the ethanol are. So, after a while, okay, you will see that, okay, there's only water left in this solution. Okay, at first it was, okay, blue with pink, correct? Water with ethanol, am I right? Okay, but now it's just, okay, water here, ethanol here. Okay, so hopefully it's clear. It's really just separate these two. Okay, some notes to take note. Okay, distillation cannot be 100% pure. This is because, for example, in the case of ethanol and water, when you heat up ethanol, okay, it undergoes boiling. That's correct. But at the same time, water also undergoes evaporation. Okay, so that's why it's said here that distillate is this one. Okay, it's distillate. You can imagine it being referred to as distillate. That means like past tense. Am I right? Okay, so it's something that's undergone distillation. Okay, so it's this portion here. It cannot be 100% pure because when you boil, for example, the ethanol, water gets evaporated at the same time. So there is some portion of water here. Okay? And the mixing of liquid, for example, ethanol and water, it will result in a lower boiling point of the substance. So whatever you get may not be accurate. Okay? So this one may actually drop to for example, 75. This one may drop to, for example, 95. Okay? Because of you mixing two different kinds of liquid together. Okay, so a few more points are that boiling chips are added to ensure smooth boiling. Okay, you can't really see it here because I drew it over, but if you refer to the first few seconds of this video, okay, you can see that there are a few black stuff here, okay? Those are boiling chips. Basically, you just have to know that they maintain smooth boiling, okay? So this is the keyword to look out for, smooth boiling. Thermometer is placed at the mouth of the exit, okay? That means it's here and not touching the liquid directly, okay? So this measures the temperature of the vapor, not the liquid, okay? Which is what we want. Okay, condenser condenses vapor back into liquid to be collected in conical flask. Okay, so and this is what is being represented here. Okay, hopefully it's clear. So really it's just to separate, in terms of color, pink and blue mixed together. I use distillation to separate out into pink and blue. But the underlying idea is that it cannot be 100% pure because some blue will always go to where the pink is. Okay, because due to evaporation. Okay, this one is very important. Okay, it will come out as a question like, why is the distillate not pure? Okay, because water or liquid B has evaporated. Okay, and hence it's in some sense diluted. Okay, this mixture here. Okay, let's move on to fractional distillation. So, with really fractional distillation and distillation really is the same thing, just that the difference is that you have added one more component. Okay, you can see that we start off with a beaker here, am I right? So this is beaker. Thermometer is here, thermometer is here. So really you can see that I've just added this small part here, which is not present here. Okay, this thing is called a fractionating column. Okay, you don't really have to know how it works. Basically, is to improve separation. Okay, this will be talked more about in the chapter of organic chemistry, which is we will dedicate a whole chapter to it. Okay, the fractions or fractional distillation. Okay, but the idea here really is just to ensure that only one liquid is being able to boil and condense at the same time. Okay, and not have a mixture like in the case of distillation, which is not very accurate. Okay, because this one, for example, can have a bit of other liquids that we don't want at a specific temperature. Okay, this one will be very pure. Okay, and only has one kind of liquid at any given boiling temperature. Okay, so that's the difference between fractional distillation and distillation. Okay, hopefully it's clear.